What's up, everybody? Welcome back to another live stream from the Scalar Learning Channel. Wow. I can't believe it, but I can believe it. But I can't believe it because we are in week 7 of 7. This is it, guys. This is our final class, and I just like I said, I can't believe we're here already, and we've kind of made it through this whole thing. Hold on, let me just turn on. I got the video playing in another stream. Anyways. First of all, to those of you guys who've been following along with this entire journey, thank you so much, and I really appreciate it. If you guys have been a part of the school JEDI community, thank you as well. If you haven't joined, here's the platform. This is where I've been looking at all the comments and all the questions that have been submitted. So I pulled everything down. We have 339 members as of today. So wow, it started 0, went to 339 over the summer. So this is really cool. We'll probably get more signups, I assume, today and throughout the week as well for people maybe who are showing up late to the party and want to go through the entire course in a week. I've seen that happen many times. If you do want to do that, and if you do join, first of all, here, let me put the URL down below in the chat. So, oops. Here it is for anybody who's jumping on the stream or jumping on the video after the fact. I'm putting it in the live chat, so make sure to check that out. Or you can go to the description, and it's in the link. The link is in the description below, and you can find it that way. But if you're in the school community, you're just joining, and you want to catch up, you can go to Classroom, and you can look at the replays of all the lectures. Right? We've got 1 through 5 here. I need to upload 6 up here, and then we've got 1 through 6 for the critical concepts. Oh, I need to put 6 up here as well. So I'll do that today, and then we'll have 6. And then obviously 7 up here today. So everything can be found here. You can even find the quizzes that I created for the critical concept videos, as well as worksheets and all that good stuff. So it's all up here. If you want all this good stuff, all you have to do is join. Everything is free on the platform, at least as of now. So make sure to do that ASAP if you haven't done so. All right. So today, without further ado, is a very big day because today you guys get to choose what we're going to do. And you guys have done that by submitting all these great questions through the JEDI community. And I'm going to take my time and go through each one of these and explain how to do these problems and also take questions on the fly to the best of my ability within the time that we have allotted today. All right. Cole has 2 questions that relate to each other. I've seen a ton of talk online that apparently this SAT is going to be very hard. Is this true? Well, if you're hearing that this SAT is going to be very hard, that's pure speculation. College Board has not said anything on that front. Now, that being said, do I also think that, I'm talking about the math portion in particular, do I think that the math is going to be on the harder side compared to what we've seen? I actually do agree with that, but again, it is speculation. But I'm going to tell you why I think it's going to be quote unquote harder. And some people might not find it harder. Some people might find it easier. I think that the College Board is going to make adjustments to the test so that a lot of the questions that have been previously really easy to answer with Desmos, it's going to be a little bit harder. So they're going to add some twists and turns. So it's not going to be so much like, oh, I just put it into Desmos and I get my answer. So I think that's going to make it more difficult. I think the College Board has realized that some of the questions were too easily solvable with the use of Desmos, hence why they've revised tests 1 through 3, which we're going to go over those later in the week as well, those revised versions. I got a big live stream planned for Friday, which I'll kind of let you guys know in the JEDI community later on. But anyways, so do I think it's going to be harder? I am feeling like it is going to be quote unquote harder, but that's also going to be a product of like they're going to throw some curveballs on there that maybe we haven't seen in the previous practice tests, I think. But again, speculation. Now, Cole's also asking, how do the curves work? Again, it's not a curve. It's called equating. So a curve is where they look at how everybody's done, the distribution of scores, raw scores, and then they assign scaled scores to those raw scores to have an even distribution, meaning we have a nice distribution of 770s, a nice distribution of 600s, a nice distribution of 550s, and so on and so forth. It doesn't work like that, at least according to the College Board, and I'm going to take them at their word. The way it works is the tests via equating are the scaled differently based on the perceived difficulty, meaning if this test is perceived, then 1 in August is perceived to be really difficult, they technically should adjust for that in the scaling. So for example, in the old version of the SAT, for a particularly hard SAT math section, you could get 4 wrong maybe and get a 780. On an easier one, maybe 2 wrong would be a 780. So that's usually how we see the difficulty manifest in the score. So you want to call that a curve, fine. It's just not technically a curve. It's called equating. Okay. What's up, Cooking 800? He says hello. Oh, I like that name. I wonder if that is a reference to in 800 on the SAT. And Cole, yeah, you're very welcome. All right, guys, without further ado, we are going to will we have time for all the questions submitted? I don't know. Let's see. I'm going to jump into it. I think we will. Because last week I did 37 problems in just about an hour. So I think this should be fun. I think we should have more than enough. And then we'll do some Q&A at the end. And obviously, I'll be back on with Dan on Thursday. And we got a bunch of other videos that are going to be released this week. So stay tuned for that. Okay, let's start with this one. I think this was submitted by Cole. I can't remember. All right, in the figure shown, AD is 121 over 3. I wonder why they're giving it in that format. Well, anyway, because it doesn't reduce. Okay, so I'm going to show you how I would do this one. So AD, first of all, remember, on the diagram or on your paper, you need to mark this as follows. So we know AD from there to there is 121 over 3. And I've never seen this problem before, by the way, so it's brand new for me. AB is 111 times square root of 130 over 3. And what is the length of DC? So this is my X value. Okay, let me think about this for a second. Oh yeah, mean proportional right triangles. They keep asking about this, and I'm gonna create a video this week that goes over these relationships. So why do I know this is a mean proportional right triangle? Because we have a giant right triangle with an altitude dropped. And what that means is we make 3 similar right triangles. 1, 2, and the big dog, 3. So the way we're going to solve a triangle like this is set up some sort of proportion. And each of those triangles are similar. So again, little side, little side, little side. Those are the little sides of the 3 respective triangles. This is the medium leg, and medium leg in order of the smallest to the greatest triangles. Okay, let's talk about how this works now. So in this medium-sized triangle, I have 2 side lengths. I have medium leg and hypotenuse. All right, so watch this. I'm going to make a proportion medium leg to hypotenuse. And let's see what we can do with this. So I got medium leg, 121 over 3. Over the hypotenuse, 11 rad 130 over 3. These are gnarly numbers. Is equal to medium leg over hypotenuse of one of these other triangles. Okay, so if I look now at the big dog, well, we have the medium leg, which is this side, and the hypotenuse, which is these 2 added together. So we can do medium leg, 11 rad 130 over 3, over 121 over 3 plus x. 121 over 3 plus x. Okay, we could solve this algebraically with Desmos. Let's do algebraically first, and I'll show you how to do it in Desmos. Let's cross multiply. So 11 rad, I mean, these numbers are crazy, but it is what it is. 11 rad 30 over 3 times itself is going to be 11 squared, which is 121. Rad 130 times rad 130 is just 130. And then over 3 times 3, which is 9. Is equal to, on the other side, this times this. So basically 121 over 3 distributed to these 2. So I'll just say whatever 121 squared is. I'll just say 121 squared for now over 9, right? Because 3 times 3 plus 121 over 3x. Okay, so we're going to solve for x. You know, at this point, now I'm going to switch over to Desmos because I just don't see the point in evaluating all these numbers in the calculator and then still keeping it linear. So watch this. We're going to type in that equation as is. So we got 121, hold on, 121 times 130 over 9. 130 over 9 is equal to, and then we have 121 squared over 9. 121 squared over 9 plus 121 over 3x. Okay, and there we have our answer, and our answer for x is 3. That's pretty much it. I wonder if there's I don't think, yeah, just one answer. That's pretty much how you do it. All right, so this length here is going to be 3. All right, so I don't have the actual answer posted, but whoever posted it, what's up, Robert King? Thank you so much. How do they measure the perception of difficulty for the test? Nazita is asking. That's a great question. I don't know. I mean, I have a rough feeling, like I can always gauge it. I'm just assuming it's like the combination of, hey, how many different subjects or disciplines you have to know to integrate it. You know, like the hybrid problems where it's a circle and a triangle and a factoring problem. I think that makes it more difficult. And then also the amount of steps or the amount of time it takes to solve it, I would guess, things like that. On these types of problems, should we go about using Desmos generally for I would definitely use Desmos. Look, you have options. I'm always trying to give you multiple options in how to solve these problems. So this I started algebraically, right? And I simplified a bit, and then I plugged into Desmos. But yeah, I could continue solving it algebraically. It just seemed like a waste of time to me, you know? Actually, it wouldn't have been that bad. I just realized we could have multiplied everything by 9 and divided everything by 121 to kind of simplify the equation. But anyways, Desmos did great. That's how you do it. All right, 22. The function f is defined by this. A and B are constant xy plane, graph of x passes through the point. Okay, I've seen this problem before. So it passes through these 2 points. Passes through that point, and we know f of 24 is negative. One thing I really like to do on a question like this is start knowing like, hey, this is a radical function, right? And a radical function typically goes like this. But, you know, that's if a is positive. If a is negative, it will go like this. But let's look at this. So first of all, we have a couple points. We have negative 24, 0, okay, which is right here. Negative 24, 0. That's our point right here. And then we also know that f of positive 24 down here is negative, meaning it's down here. Okay, so we know that the shape is usually like this, but for some reason it's giving these 2 points, which means the shape is going like this, okay? Moreover, if the shape is going down like this, my A has to be negative, and I know this is probably going to be my vertex. I'm going to tell you why. And you don't have to know all of this, by the way. I'm going to show you different ways where you can solve this without knowing these general parameters of a radical function and the graph. But, you know, this is showing me the horizontal shift. The vertical shift would be out here. Like if it said +3, then maybe that vertex would be up here. But there's nothing there. So I know this is starting on the x-axis, which means it's got to look like this, meaning A is negative, and B is going to move the vertex back to negative 24. The only value that's going to do that is if B is positive 24. Okay, let's think about why. So we still don't know what A is, but I'm going to say B is positive 24 because think about it. When you plug in negative 24 for x, that's going to zero out this function, right? And that gives us a 0 value for the function value, so that makes sense. Okay. So now we know that that's the case. Now the question is, what is A? We know B is equal to 24. And all I know is that A is negative, right? Because I'm telling you to go down like this, A has to be negative. Now, I could plug in 24 over here, and I could solve for A. But really, look at these 2 options, right? They're saying, is A greater than B? And I know that A is negative. Or is A less than B? A is less than B. B is 24. A is negative. It has to be D. And we're done, okay? Now, we can look at this. I think somebody chose f of 0 is negative 24. It's actually f of negative 24 is 0, right? F of 0 probably isn't negative 24. I mean, actually, it could be, but it doesn't have to be true. F of 0 being 24, no, that's not true because it says this. So we could pretty quickly eliminate A and B, and then it's down to these 2. Okay, let me think if there's another way we could do this. If you plugged in... Yeah, I mean, the other way we could find B is you could plug in negative 24 for x and plug in 0 for f of x, and you could solve for B that way. And let's see, what's another thing we could do? Oh, yeah. Okay, now let me show you a clunky way to do this in Desmos. So we have A rad x plus B, right? A rad x plus B. And we're going to do this. And now let's say we got to the point where we know that B is 24. Okay, cool. So now we see this point occur right here. And we know that f of 24 has to be negative. Right now it's positive. So, you know, I know B is 24, so how do we change A? Oh, no, that looks like it's going in the wrong direction. And then, oh, A has to be negative. That's the only way we're getting a negative value for the function at x equals 24. So now we can see, like, I don't know exactly what A is, but I know that A has to be negative. And now we see that A has to be less than B. Okay, let me know if that makes sense, guys. How often these kind of questions, A or B? Oh, you're going to see one almost every time. What's up, Encore? Oh my God, now I'm stressing for this. Wait, what do you mean? Why are you stressing, Cole? You're doing great. You should be the last person that's stressing. You've been doing everything and showing up everywhere. So you should not be stressing at all. And look, if they throw a couple super hard questions, if they throw 1 or 2 on there that throw you for a loop and you get them wrong, big deal. You're still going to get a really solid score. A lot of people are going to get those crazy ones wrong. So it's not going to impact the curve that greatly. All right, let's move on to 21. So this is let me move this down so we don't get confused here. Or let me zoom in a little bit. Okay, so we're looking at this one right here. This is from one of the practice tests. Everybody has problems with it. It's also on my SAT 38 hardest digital SAT problems. So you can also Google that and watch me do this carefully. But let me write this out. So this is a very important question because there's a formula in here that's kind of hidden. Okay, so you got to figure out what this formula is. By the way, guys, I see we have a nice little audience of everybody online today. If you guys could give me click the like button if you are enjoying the content and like what you see, it really does help the channel out tremendously, so that'd be fantastic. Okay, for an electric field passing through a flat surface perpendicular to it, the electric flux, let's say F, of the field through the surface is, that's my equal sign, the product of the electric field strength and the area of the surface. I just created an equation just from this sentence, and you might have missed that the first time you read it. So very important to extract any and all equations or relationships. So again, electric flux is the product of the field strength to the area of the surface. So there we go. Okay, and there's my first equation. Then it said a certain flat surface consists of two adjacent squares. Let's draw them out. Boop, 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 like this. Where the side and length in meters of the larger is 3 times the length of the smaller one. So this one could be x by x. These side lengths would be 3x by 3x. Great. And by the way, and we're going to talk about the area of this square, but we're going to come back to that. An electric field with strength of 29 volts. So again, that's the strength. So let's color code this a little bit. We got strength of 29. And pass uniformly through the surface, which is perpendicular to the electric field. The perpendicular is a little bit of a red herring. You don't really need to worry about that being perpendicular. But anyways, and then it says, if the total electric flux, that's F, is this. Okay, so let's just pause here for a second. This gives us enough information to solve for area. And that's the first step. Let's stop here, and then we're going to read the rest of it afterwards. And I know you might, well, okay, actually, let's read the rest of it. It says, eventually, we need to find the electric flux through just the larger square. But to get that, we need to know the area of the larger square, which means we need the area of the entire figure to solve for x, so on and so forth. So let me show you how this works. My flux value, which we said is 4640, is equal to my strength, which is 29, times the area. Now, I could leave it as area and just solve for that. But why not go straight to the source? Why not solve for x? Because when I can solve for x, then I can figure out the area of just the larger square much more easily. So what is the area of these two squares in terms of x? Well, this one is x squared. This one is 3x times 3x, which is 9x squared. Adding those two together, I get 10x squared. Now I got this beautiful expression that I can solve. So I got 4640 is equal to 29 times 10x squared, which is 290x squared. We're going to divide both sides by 290. Hold on. 4640 divided by 290. 1 second. 4640 divided by 290. That's 16. What a nice, beautiful square number. So that should give you confidence, right? So 16 is equal to x squared, which means x is equal to the square root of 16, which is 4. That means the larger square is 12 by 12. Okay. So now they want to know the flux going through the area of the larger square, which we know the area now is exactly 144. So let's use the same equation. What is the flux when we have the same strength, they didn't change the strength, of 29 times that area, which is 16? I mean, wait, did I say 16? I'm sorry, 12 by 12. Sorry, 12 by 12, which is an area of 144, excuse me. And then 29 times 144 gives us that nice answer of 4176. 4176, boom. All right, guys, let me see if that made sense. Do all the questions in the test have to be in the question bank? What do you mean by have to be in the question? They probably are in the question bank. I don't know if there's a rule per se, but the way they slipped the total in there is why I got this wrong. Yeah, totally. Hope your day is going well. Yes, I hope so too. Okay, by the way, would you guys do me a favor before we go to the next question? I'd love to know where everybody is from, where you guys are studying from. You can either, if you're in the U.S., you can tell me the state you're in. If you're international, you can tell me the country or the city you're in. Just love to know where all of our audience is tuning in from. That'd be super cool. Oh, yeah, somebody says, any predictions on the August SAT? Those will be coming out later in the week. Yes, I have a big predictions video that I'm working on right now that will be coming out. Okay. Now we got this problem. These are very difficult. 2 identical rectangular prisms. So one of my main rules when you see something about a geometric figure and it's not given, must draw it out. Rectangular prism is just a box. So we got 2 identical rectangular prisms. Boom, boom, boom. And they have, the base of each prism is a square, meaning the side lengths are equal. Boop, 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 boop. And they have a height of 90. Height of 90. Great. And the surface area of each prism, meaning one prism, is K. Then I'm gonna create, that's a relationship right there. We're gonna make an equation in a second. But then it says when they're glued together, I'm just gonna draw it out, along one of those square bases, boop, 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 like this, we have a surface area of this. That's another relationship. And again, we have the height of 90, 90, and still that same base, x by x. Okay. What is the side length of the base? Well, this is beautiful because we already have a variable for the side length of the base. Now we just need equations. Okay. So what was that first relationship? Well, excuse me. It says that the surface area of one of these prisms is K. What's surface area of the prism? It's the top and the bottom bases, which is x squared and x squared, so 2 of those, plus the lateral surface area times 4, right? Because there's 4 faces on the lateral side. The area of one of these faces is 90 times x times 4 is 360x, and this equals K. Okay, great. We have one equation. Then the glued together figure is this weird fraction, which is really annoying, but it's not that bad. So how do I represent this as an equation? Well, the surface area here, again, we have the top and the bottom, 2x squared. What happened to the middle bases? They've been consumed. They're within the figure, so they're not on the outside. They're not part of the surface area anymore. And then what about the lateral surface area? Well, again, I still have the 360x for the top one, the 360x for the bottom one. That's doubled. So that's 720x is equal to, let me just make a little bit of room. I'm going to erase one of these, is equal to 92 over 47k. 2 equations, 2 variables. I'm essentially done. Okay, but here's the part where we're going to probably want to use Desmos. Could I solve this algebraically? Sure. But is it going to be a little bit of a nightmare? Yeah. So I'm going to go to Desmos, and I'm going to write these in. So let's do that here. We got 2, hold on one second. 2x squared plus 360x equals k. And I may change k in a second. Actually, I'm going to replace it with y. And then we have 2x squared plus 720x is equal to, what was that fraction? 92 over 47, right? 92 over 47 y. So you're like, great, I got a system. Now I just look for the intersection point. Not so easy to find, right? So it's like a crazy big function. It's really tough to find the intersection point. Actually, wait, let me see if we could, I will try and find it, but it's going to be pretty hard. Let's go from negative, I don't know, 12, negative 12 to 12. And let's see if this helps a little bit. Yeah, it's so pretty hard to find the intersection point. Okay, so anyways, so let's say we hit this roadblock and you're like, man, I can't find the intersection point. This didn't work. Desmos failed. The other option is, wait a minute, I can use a little algebra, right? Within Desmos. I see that y equals this. Why don't I substitute? So I'm replacing y with 2x squared. Hold on. And I'm not copying and pasting because I know you can't copy and paste on the Desmos within the SAT. So I'm just retyping it. And then now let's just turn this one off. This should be showing the exact solution of y, or maybe, sorry, in terms of x. Oh, what the heck? Did I zoom in too far? Oh yeah, I zoomed in way too far. So we got one solution at 0. Now, obviously 0 would work, but that's not a real rectangular prism, right? So that's not the viable answer, but there's our second solution. That's the good one. And we see that 8 is the winner. That's how you do it, okay? So this one, the side length of the bases is 8. Boom, done. All right. Cole, is everything changed? Wait, let's see here. Oh, Florida, Virginia. Amazing, amazing. I'm very confused. How come some questions I see from the practice test are different from my practice test? Oh, because they just updated practice test 1 through 3 2 weeks ago. So there's a new practice test 1 through 3. I'm going to be redoing my live streams for all those tests this week, so don't worry. All right. I'm so confused on Module 2 math, especially questions 19 through 22. Yeah, that's the hard part. Those are the really difficult ones. Oh, yeah, Cole already answered that question. Not everything, only a few questions per test. Yeah, that's right. Not everything has changed. Thank you, Cole. Cole knows his stuff. Okay. Now let's go to this one. What is the area in square units of the triangle formed by connecting these 3 points? All right, interesting. Let's connect the 3 points. And so I've never seen this problem. Let's take a look. Yeah, let's make these a little thicker. I don't even know if this is a right triangle. It looks like it's not. So down 1 over 3 over 8. And then this one is up 6 over, yeah. So that's not a right triangle. Very interesting. How would I do this one in area problem? I mean, there's a, we could use, but we don't have any angles either. Hold on. By connecting the 3 points. Wow, this one's pretty tricky. Let me think about it for one more second. Because if these two sides were perpendicular, then we could do it. No problem as a typical triangle. So let me just think about this as well. I know there's a trig formula, 1/2 AB times sine of C. There's no way they're gonna want you to do that, because like I've seen them want you to use it on the ACT, but not on the SAT. And we don't even know what that angle is. Let me think about this for a second. Oh, wait a minute. We can do, hold on, let me just make sure I'm looking at those lines correctly. Because what I could do is I could draw something down here. I could draw an altitude. Hold on, let me think. And if you guys have ideas, can you make a rectangle and subtract? Yeah, but again, it's not a right triangle. It's not a right triangle. Oh, great idea. I see what you're saying. Oh, that is the way. Look at this. I didn't think about that. So smart. Who said that? Cheerio. Well done, Cheerio. Smart. I don't think anything like this is going to be on the test, but yeah, you can make a rectangle. Very, very clever. Good work. Okay, so we have a height of 7, and we have this come across by 8. So the area of the rectangle is 56, and then we minus each one of these triangles. What? That's cool. Okay, so this one is 1 by 8 right triangle. So you do base times height divided by 2, so that's an area of 4. So this triangle is 4. Hold on, let me make this less thick. This one is 1 by, what is this? 1, 2, 3, 4, 5, 6. So 1 times 6 divided by 2 is 3. This one is 7 by 7, right? So 7 times 7 is, 7 by 7 is, doesn't look like 7 by 7, right? Oh, it's because it's just stretched out that way. Anyways, whatever. So 7 by 7 is 49. Divided by 2 is, we'll say 24.5. Okay, so those are the 3 triangles we'd subtract. So let's add them up. So it's 7 plus 24.5. 3 is 27.5 plus 4 is 31.5. And then we minus these 2, right? So 5, 10. So we got 5, 4, and 2. And that's it, 24.5. Wow. That was crazy. This is hard, but really good idea. Yeah. Let's see. Can you use distance formula to solve for the angle? Yeah, but again, I don't think that's what they want you to do. But yeah, you can. I mean, wait, you said use distance formula to solve for the sides. Yeah, again, like you're not supposed to use law of cosines or law of sines on this test, but you could, I suppose. Thank you so much for your videos. You have no idea how much you save all of us. By the way, will all your videos be posted? Yeah, everything's going to be posted, so you're good. Cheerio's a really smart man. What? Yeah, Cheerio, legend. Good job. That one got me stuck for a second. Well, very nice. All right. Aren't these live streams so much fun, where we can interact and ask questions and comment? You guys can help me out. So good. All right, here we go. In the expression above, b and c are positive integers if the expression is equivalent to x plus b. Equivalent. So I'm going to set it equal to. No problem, right? And x does not equal b. This is just so we eliminate the possibility of dividing by 0, so pretty much ignore that, which could be the value of c. Okay. So I've got my equation. There's a couple ways we can do this, but this is what I'm going to do. This is just the first thing that comes to mind. I'm going to multiply the denominator over there. So we got x squared minus c is equal to x minus b times x plus b. Now, as we FOIL this, boom, 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 we get x squared plus bx minus bx. Those are going to cancel out. Minus b squared, which means that x squared minus c is equal to x squared minus b squared. Cancel those out. Negative c equals negative b squared, meaning c equals b squared. Okay. So c equals b squared, which, okay. So c has to be positive. Oh, here we go. Here's the kicker. I should have underlined this. Sorry, guys. B and C are positive integers. So which is the value of C? If B is an integer, okay, that means the square root of C has to be an integer because that will be B. You notice that, right? So which of the following could be the value of C? It's got to be A. Only A, because A is the only perfect square. Because if C is 4, B would be 2. If C is 6, B would be the square root of 6. That's not an integer, so that violates that rule. Okay, I hope that makes sense. Let me know, guys, if you have questions on that one. But that's about it. Wait, let me see if there's another way we could have done this. I'm trying to think if there's a way to use Desmos. I guess it's a little hard. Yeah, I can't think of a great way to use Desmos here, so I think that's the best way. All right, according to the data provided by the use of environmental energy, average price per gallon, regular gasoline, average price per gallon. Gasoline is modeled by the function f of x, so here's our function. It's a linear function, okay? All right, so 2.74 in this function estimates which of the following. All right, so this is a linear function, even though it's in this weird format, right? And the slope is going to be negative 0.19. But my y-intercept, as I've talked about in my critical concept videos, the y-intercept is always your initial value, your starting value. So since we're starting from September 1st through December 1st, I imagine this value has something to do with September 1st, right? And since it's the y-intercept, that's the y value and when x is 0 or 0 months. So that means 274 should be the price. And notice how I'm answering it before I'm looking at the questions. It should be the price per gallon on September 1st. Nope, that's rate of change. The difference in average price. No, it's not a difference. It's this one. The average price per gallon. Wait. I'm saying the answer is D. X months. That's 0. Oh. Shoot. I just missed something. I almost got fooled just now. I was going to go with this. It's not. I just realized why. This isn't a true y-intercept. It's not a true y-intercept. So because of this format, you'd actually have to distribute and then combine those. And the y-intercept is actually 3 times that, which is 0.57 plus 2.74, which is 3.31. 3.31 is the real y-intercept. Oh, my God. Okay, so this is a very tricky problem. I see why it's D now. I'm glad I posted the correct answer there because I almost would have made a little mistake. This is a very tricky one. So here's the deal, right? This is the y-intercept, or would be the y-intercept if when you plug in 0 for x, that's the value you get, but you wouldn't. You plug in 0 for x, you get -3. -3 times that again is 0.57, which added to this gives you this, right? So in reality, the 274 is what you get when you plug in 3 for x. Because 3 minus 3 is 0. That zeroes this out, and then you get 274. So that's the price 3 months after September. So think about it like this, right? We have September 1 when x is 0. October 1 when x is 1. November 1 when x is 2. And when x is 3, we have December 1st. Hence, that's the value when you're plugging in 3, and 3 is the price in December. Okay, I hope that made sense, guys. Wow. That's a great one, whoever submitted this. Okay, once you get b squared equals c, you can use arbitrary values. Oh, stock. He's going back to the last question. Yeah, you could have used Desmos once you make that relationship, but it is kind of important to get that relationship, and then kind of once you have it, maybe you want to do it algebraically. Well, yeah, you could of course jump into Desmos then. Great comment, stock FZSH. Let the function p be defined as follows, where c is a constant, p of c is 10. What is p of 12? Okay, very nice. Let's see, what would I do here? So we know that when you plug in c, you get 10. All right, so let's start by that. Let's plug in c for x, and we know that the function value is 10. So c minus c is 0. So then it's 160 over, and then you've just got over 2c, because c is just c. We multiply both sides by 2c. We get 20c equals 160. Divide by 20, and c equals 80. Great. So now we got a value of c, which is 80. So now we know it's x minus 80 squared plus 160 over 2 times 80, which is 160. And then it says, what is P of 12? Again, function notation, meaning we're plugging in 12 for X, right? So we got 12 minus 8. Should I do this in I'm going to do this in decimals. Hold on. 12 minus 80 squared. Here, let's do it here. 12 minus 80. Whoops. Sorry. Squared. And then what is it? Plus 160 divided by 160. Hold on. Does that look right? No, that wasn't one of the options. Let me see if I made a mistake here. X minus 8. Oh, did I say 60? Sorry, it's supposed to be 8. No, 80. 12. Hold on. Did I make a mistake? P of 10, 20. Oh, it's 8. Oh, my God. Sorry, guys. It's 8, not 80. Whoops. Okay, there you go. Fixed it. Let's go back. So it's 8, and then it's 16 on the bottom. And there we go. We get an answer of 11, and 11 is correct. Yowzers, making some silly mistakes here. All right, did that make sense, guys? Let me know if that did in the comments. Let me know if that didn't in the comments, okay? So let's check that out. All right, moving along. Next question that was submitted. The total distance d in meters traveled by an object moving in a straight line can be modeled by the quadratic function is defined in terms of t, where t is the time in seconds. At time t of 10 seconds, the distance traveled is 50. So we got time and distance. At time 20, distance traveled is 200. And at time 0, its distance is 0. Distance of 0 when t equals 0. What is the total distance traveled in meters by the object after 30 seconds? Okay. So let's talk about this. So first of all, we've got 3 points in a typical quadratic equation. Let's do it in terms of d and t. D is equal to at squared plus bt plus c. So we have 3 constants that we need to flesh out. But here's the thing. The x-intercept, which we see as 0, 0, is going to be that's going to be the value of c, right? And I'm sorry, y-intercept, excuse me. So my y-intercept, I already see it here. It's 0, 0, which means that c is also 0. So we didn't need to solve for c. But we do need to solve for a and b. And the great thing is we have 2 coordinates. So now we can plug and chug and figure this out. So I know that when d is 50, hold on one second. When d is 50, t is 10. So 10 squared is 100. A plus 10 times b, which is 10b. My second equation, when d is 200, I know that t is 20. So 20 squared is 400a plus 20b. Either way, I remember this problem. This is from an old version of the SAT. I think in 2019 or 2020. I can't remember. But anyways, it's a very hard question. So now we basically have a system of linear equations to solve for a and b. So let's solve it. I'm going to just do it by hand. Let's use elimination. I'm going to multiply this by -2. That's how we can eliminate b. We get -100 equals -200a minus 20b. And again, with elimination, we're trying to line up 2 of the coefficients, but to be opposite. So when we add them together, they cancel out, which they do. And then I have 200 minus 100 is 100, is equal to 400 minus 200, which is 200a, divide by 200. And a is equal to 1/2, right? And if a is equal to 1/2, we can now solve for b. Let's plug it into this equation. So a is 1/2 times 100 is 50. So 50 equals 50 plus 10b. Cancel, cancel. 10b equals 0, which means b equals 0. Okay, interesting. So our equation is simply d equals 1/2 t squared. Very nice equation. Now let's make sure this works. If I plugged in 10, would I have gotten 50? 10 squared is 100 times 1/2 is 50. When I plug in 20, do I get 200? 20 squared is 400 times 1/2 is 20. 0, 0 obviously works. There I got my equation. Now it says, what is the total distance traveled when t is 30? Plug and chug. 30 squared is 900. Half of 900 is 450. That's how you do it. All right. Does that make sense? Whoa, I didn't know they could be in terms of coordinates dt. Yeah, but again, coordinates dt, you could also translate it to y and x. D could be y, x could be t. So you don't have to play their game. I just did it that way because that's how they set it up. So don't let the different letters throw you off. Let me erase all this stuff here. Okay. Moving on. The table shows three values of x and their corresponding values of y, where f of x where y equals f of x plus 4. So this is for f of x plus 4, shifted up, right? And then it says, what is the y-coordinate of the y-intercept of f of x? All right. So I'll tell you what. This is how I'm going to show you how to do it, because I know people get confused with these transformation problems a lot. Like you could say, hey, f of x, we just shift the y down by 4. And sometimes people get confused. They might do it backwards. So watch this. Ready? What is this equation? Let's see. Well, we got a couple coordinates. We only need 2 because they're linear. Oh, no, it says quadratic. My bad. Never mind. Let me back up on this. Hold on. I was going to get the linear equation, but f of x plus 4. Oh, okay. I know what we can do. So we can actually make an equation for this because since it's symmetric around 23, I'm kind of going deep on the knowledge that I'm leveraging, but not that deep. But if you look at this, when these two are equal, you know that they must be perfectly around the line of symmetry and around the vertex. And they're both 2 away from 23. So we have the vertex and we have points. So f of x plus 4 is therefore equal to some value a times x minus 23 squared plus my y value of the vertex, 8. Now the question is, what is a? Well, to get a, all I have to do is know, what are we plugging in here, right? For y to have a certain value of x. So for example, this function is equal to -8, when x is equal to 23. So I'm sorry, when x is equal to 21. So 21 minus 23 is -2 squared is 4, 4a plus 8. Minus 8 from both sides, -16 equals 4a, divided by 4, a equals -4. So now we have this. Let's back it up. A is -4, and we have our equation. So we have f of x plus 4 equals this. I want to know what f of x is. Well, guess what? Just -4 from both sides, right? -4 minus 4, 8 minus 4 is 4. Now we have our equation for f of x. So then it says, what is the y-coordinate of the y-intercept? What is the value of x for the y-intercept? It is 0. So now I've got a beautiful equation. I just plug in 0 here and solve. So 0 minus 23 is -23. -23 squared, let me do that in Desmos, same as 23 squared, is 529. And then we're going to multiply that by -4 and then add 4. So multiplied by -4, and then we're going to add 4. And there we go, -2112. -2112 is the answer. Boom, done. I'm trying to think if there's anything else you could have done with this one. Let me think. Because if you would have plugged in, you could have, I guess this is shifted up. So I guess you could have also, if you didn't like this, you could have just been like, all right, let me just drop all of these by, or sorry. Yeah, drop all of these by 4. So this would be -12. This would be 4. And this would be, hold on one second. Oh, yeah, sorry. This would be -12, right? So we have these 3 values, and then you could have just done it this way to get f of x. I don't know if that's easier for you guys, but there you go. All right. So Cole says, wow, I've only been studying the hardest problems in the past weeks for many hours. I hope we'll be able to do questions 19 through 22. I hope so too, and I hope this helps. These questions are saving our scores. Yeah, exactly, Cole. You shouldn't be sorry. You probably picked really good ones for everybody. Okay. All right, we got the next one. Triangle RST. Angle T is the right angle. Okay. And we've got point L lies on RS. So we got L. Point K lies on ST. Oh, boy. Hold on. Wait. I might need more room here. Let me make a better drawing. This one looks intense. Okay, let's do a better drawing. Boop, boop, doop, boop, boo. Do, 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 do. And this one. Okay. All right, let me try this again. So we've got line, what does it say? T is the right angle. So we've got R, S, T. And does it say what is the... Oh, it also says if the length of RT is 72 and the area of RST is 792. So, oh wait, I can get TS as well because 72 times this divided by 2 is this. So 72x divided by 2 is 792. So let's see what that is. We'll multiply by 2 and divide by 72. So 792 times 2 divided by 72 is 22. Okay. So I know that this value is 22. All right, I'll tell you what. I'm going to flip this around so it looks better. So I'll make this R and this S and this R. So then we've got this side. I hope you guys are following me. I'm just doing this for you guys. You guys don't necessarily have to make it look to scale. All right, so now we know RT is 72. We know ST has to be 22 to get an area of 792. We could also use Pythagorean theorem to find SR. But anyways, we're trying to find KT. All right, now let me put in these other things. It says point L lies on RS somewhere here. We've got K lies on ST over here. And we've got, what else? The length of LK is 24. Let me draw that in. Where did you find this, Cole? This is insane. Okay, 72. So RT, wait, KL is the same as, wow, how is that the same? So it must be like, here, let's see if I can get a better drawing because it would probably look like this. Here, let me show you. It would probably have like K here, and we'd probably have like, I guess L over here. I don't know. It's pretty tricky to do that, but at some sort of an incline, right? So let's say like this. It looks a little bit better. The length of RT. I'm sorry. The length of, guys, let me back up. I am just not reading things correctly right now. Excuse me. Let's go back to how I had it before. LK is only 24. So L. There we go. L lies on RS. K lies here, and we got 24. All right, let's see if we can piece this together now. Great. The area of RST is 792. What is the length of KT? So we need the length of KT, which is this distance down here. Okay, so that's what we're solving for. And let's see what we can do here. Oh, and it also says LK is parallel to RT. All right, that's much better. I have not done a good job of reading this, guys. I'm kind of like doing it on the fly, and I missed a lot of details. That makes it a lot easier, and I'm going to show you why. Okay, so now we're trying to get this little chunk here. And now we can totally do this. A lot of those details were very important. So what are you noticing here, right? We're noticing a right triangle, and we're noticing a bigger right triangle. And both of these right triangles share this angle, meaning by angle similarity, we know that these two triangles are similar, aka proportionate. So we can use this to now make a little proportion, okay? So watch this. For the big dog, we've got little leg over big leg, okay? Is equal to, for this mini triangle, little leg, which I'm going to label up here as x. I know we're not trying to solve for x. We're trying to solve for this, but just give me a chance. We got little leg over big leg, which is 24. Now we can solve for x, so let's do that. We're going to cross. You know what? Yeah, cross. So we got 72x equals 22 times 24. I don't have that memorized. 22. It's 528. Probably could have done it, but it's all right. And then we're going to divide by 72. We get 7 1/3 or 22 thirds. I'm going to leave it in fraction format. That's a good little tip, by the way, to click that button to get the fraction. So we got 22 over 3. So x is 22 over 3, but that's not our final answer, right? Our final answer is this blue chunk, but we can get there because we know the full length is 22. So we have 22 minus 22 over 3. And I like to leave this in mixed number. I can turn 22 to have a denominator of 3 by multiplying it by 3. So we have 66 over 3 minus 22 over 3, which would give us 44 over 3. There's your answer, 44 over 3. I need to know what you guys think of that question. That's tough. College Board question bank. Can you please show it? Yeah, I know you got it from the question bank. I was just joking. I can tell from the formatting. Just want to make sure I have my head wrapped around it. Yeah. Could you make an equation with one of the smaller triangles missing sides? What do you mean by that, MC? 44/3. Could I make an equation with one of the smaller triangles missing sides? I'm not sure what you mean by that. If you could clarify, let me know, and I can answer that. But I hope that makes sense for most of you guys. All right. Another geometry one. ABC is similar to DEF, and it does say they're both right triangles, so let's draw them out. Boop, boop. And C and F are the right angles. C and F are the right angles. And I'll just do it arbitrarily. A, B. No, let's do it the other way. No, that's fine. A, B, and then we've got D, E. So D, E, F, A, B, C. Okay. And it says tangent of A, meaning opposite over adjacent, is rad 3. Okay. Right off the bat, I'm going to assign values. It doesn't have to be rad 3 and it doesn't have to be 1, but it can be. So why not, right? This is a possibility. Now, if we want to get more specific in terms of like, just representations, we could also say 1x and rad 3x. That leaves the possibility open. I think for now, though, we can just say this. This is fine. So we have 1 rad 3. Now, hopefully you recognize this is a special relationship. What is it? It is a 30, 60, 90 right triangle where the smallest side is 1 and the medium leg is rad 3. That means the big hypotenuse is 2. Okay. So we know we got a 30, 60, 90, right? This is 60, this is 30 as well, because these are similar. They're going to have the same angles. Okay. Now it says that DF is 125. What is the length of DE? So immediately you see this 1 to 2 relationship. We're going to have the same 1 to 2 relationship here. So double 125 is going to give us the hypotenuse, which is 250. D is the winner. Does that make sense, guys? Oh, MC says I did exactly that. All right, great. So I hope that makes sense. Okay, we got another one. Here we go. U minus 3 equals this. What is T in terms of U? This is an isolating quantities question. So this is how I want you guys to think about it every time. Just ignore. Well, you see what's isolated? T. Great. So I need to get T by itself. T is in the denominator. That's a problem. I'm going to multiply both sides by that denominator. So I have U minus 3 times T minus 2 is equal to 6. Now you might be like, all right, now I'm going to distribute and do my thing. That would be way more work than you need to do. Instead, at this point, I want to isolate T, so I'm going to leave this alone. I'm just going to divide both sides by U minus 3. Nice and simple. Goodbye. Now I have T minus 2 equals 6 over U minus 3. Last step, add 2 to both sides, and there we go. Now, I don't see this option, but I know this is correct. So we can do one of two things, okay? We can try and get this to look like one of these, which is what I usually do, or we can use Desmos. So I want to show you how we can use Desmos, okay? So this is my answer. 6 over U minus 3 plus 2. So watch this. 6 over U minus 3 plus 2. And I'm going to add a slider, and I'm going to choose an arbitrary value of U. I'm going to say 2. Now I'm going to plug in these other options, and I'm going to see which one is going to give me that same output of -4. And that's the equivalent representation. Obviously, I can see, let me write that down. U is 2, right? Actually, maybe I can do this by hand real quick. So 1 over 2 is not -4, out. Plug in 2 here. I get 4 plus 9 is 13 over 2. That's not -4. I'm trying to get -4, by the way. Over here, 1 over 2 minus 3, that's -1. This is out. And then this one's got to be the right answer. 2 times U is 4 over 2 minus 3, which is -1, which is -4, which means D is the winner. Now, how would I do this just straight algebraically? Well, what you see here is they have a single fraction. I have a fraction, rational expression, we could say plus that. I want to get them consolidated. So let's get a common denominator. So that's 2U minus 3 over U minus 3. And then 6 over U minus 3 is being added to that. So we're going to distribute 2U minus 6. So we got 6 plus 2U minus 6 over U minus 3. Cancel. And we get 2U over U minus 3. And that's the equivalent expression. So that's another way that you can do it algebraically and get to that right solution. This may make more sense and be more intuitive for a lot of people. And if so, there you go. Okay, moving on to the next question. We got a quadratic. In the given quadratic, a and c are constants, is a parabola that opens upwards. So I like to draw that. And oh no, actually wait, let me not draw it yet. And has a vertex hk where h and k are constants. It says k is less than 0. And I don't know what h is, right? But I know that k is negative. And I also know that f of negative 9 equals f of 3. Okay, so what does that really mean? Well, we know that parabolas are symmetrical, right? And if these two are equaling each other, that means that I've got points like this and like this, which means my vertex or my line of symmetry has got to be right in the middle of these two. Now, these two are 12 apart, so my vertex is going to be 6 away from this and 6 away from this, which is going to be at negative 3. Also, because it says k is negative, I know my vertex is below the x-axis. So just like this, I've got a pretty good drawing of what this parabola is going to look like. It's not perfect, and I don't know for sure, where these values are, or maybe they're on the x-axis. I don't know, but this is a good general idea. And I do think this graph helps, like a little rough graph, okay? Oh, I think the formatting is a little bit weird here. Oh, yeah. I think this is 1, and this is probably 2, because I've seen this question before. It's from one of the practice tests. All right. So now let's go through, and we got c is less than 0 as a is greater than or equal to 1. Well, first of all, I can find h, right? And I'm going to show you why this is important in a second, because h is the x value of the vertex. I know the vertex is at negative 3. So negative 3 comma k. So h is equal to negative 3. So that's pretty useful, right? And the reason why this is great is because I know that we have a formula, a shortcut in standard form, negative b over 2a equals my h value, right? Equals my x value of the vertex, which is h. Okay, well, what is a? A is a. What is b? B is 4. So I know negative 4 over 2a equals negative 3. I have an equation I can solve for a. So we're going to multiply both sides by 2a. Sorry, I'm going down here. Negative 4 equals negative 6a. Divide by negative 6. A equals 4 over 6, or 2/3. I have a concrete value of a. So I can immediately say, is a greater than or equal to 1? No, it's not. It's not, because a is equal to 2/3. So 2 is out. That one's out. So now the question is 1 true, or is it neither? Okay. So the way I've drawn it, c out here, is the y-intercept is actually less than 0. But the question is, does it have to be? Right? So now we can kind of play around with this. So let's see. We've got 2/3. I'm going to go into Desmos. 2/3 x squared plus 4x. Hold on. 2/3 x squared plus 4x. And then we don't know what our c value is, right? Okay, hold on. Let's go home and let's reset it. Okay, so here c is 1. Right? What was the restriction again? C is less than 0. So here C is 1. I don't see a problem with anything, right? We've got our vertex at negative 3, negative 5, which is totally appropriate. We've got the value of, what was it? F of negative 9 equal to 3. Here, let's see. F of 9. We've got the symmetry lined up perfectly. They're both at 19. And, right, that's it. But what if I modify C and make it negative? It still works. We still have our vertex right in the right spot. We still have these two values coming out to be equivalent. So I don't see why we have a restriction that C has to be negative. I think I drew it here that way, but as you can clearly see, it doesn't. So I would say D is the winner. Done. Hope that made sense, guys. I feel like one would run out of time without a calculator. Yeah, probably without a calculator, you would run out of time. They're setting it up so that you can use a calculator. They're making it more difficult because of the access to Desmos. And I think they realized that after the fact, which is why they're modifying the existing practice. It's obvious. Not trying to throw shade at the College Board. I mean, it's just what's happening. I'm sure they had a lot of things that they had to manage in this transition. So, these are just some of the bumps in the road. All right, which of the following are a factor of this? When I see a question like this, I think this is 1 and this is 2. Again, I don't know who submitted this, but the formatting is a little funny. So again, immediately I see factor. I'm going to factor this, right? If it's factorable. Wait a minute. Instead, Now I'm going to, it's going to be a pain to factor this using the star method because the numbers are so big. I want to see if this works. Hold on. I'm just telling you what I would do in real life. Like if I saw this question, I would try this and see if it worked. 3x squared, negative 7x, negative 27x, and positive 63. So that doesn't work. Wait a minute. This immediately tells me, I think it's one of these is wrong. Wait, hold on. Let me think. So we have negative 7, positive 27. So if you switch this, it would work. That was just a happy accident, I think, kind of from trying this. But look, 3x squared minus 7x plus 27x, that gives you the 20x, and then minus 63. So you see, x minus 9 is not, but 3x minus 7 is legit. All right. Now, another way you could do this is if these are both factors, these tell you where the zeros are. So that means if this is true, we'd have a 0 at 9. If this is true, we'd have a factor at 7/3. So another way you can do this and plug this into decimals. Watch this. 3x squared plus 20x minus 63. Hold on. So we do have a factor at 7/3, so that one's legit, but we don't have a factor at positive 9. We have one at negative 9, which again shows that the correct factoring is x plus 9, 3x minus 7. Can you use Desmos? And look at that. Yeah, absolutely you can. You just nailed it, Nazito. Well done. I think you said that before I did it, so great job. All right. This is a hard one, but you're going to see it's not as bad as it looks. Watch this. Ready? So you see this crazy equation. I'm going to follow my general principles. Let's get all the variables to the left side. So I'm going to subtract this entire expression to the left side. I have x squared minus c squared over square root of x squared minus c squared is equal to 39. Now, what you might notice at this point is this expression is to the first power, and a radical is the same thing as taking something to the 1/2 power, and they're the same expression. Okay, so if they're the same expression, you just subtract the exponents. Now I'm left with x squared minus c squared to the 1/2 power, which is the same as square root. This would equal to 39. Now you just isolate x. So we square both sides. X squared minus c squared is equal to 39 squared. I'm going to leave it as 39 squared because they have it as 39 squared in the answer choices. Now I'm going to add c squared to the other side. And then I'm going to square root. And it's equal to plus or minus square root of 39 squared plus c squared. And that is going to be c because it's plus or minus, right? Or no, sorry, d, excuse me, because it's plus or minus. So it's just the negative version of c squared plus 39 squared. Another way you could do this with Desmos is, let's see, once we get to this point. Oh, yeah. Another way you can do this with Desmos, I forgot. You can plug, I'm not going to do it because it takes forever, but you could do it if you have enough time built up. You can plug this equation in, right? Oops. Plug this equation in as is. Set something for C. Set C to 2 or 3 or something. It doesn't matter. Just not to 1 or 0 ideally, but set it to like 2 or 3. And then whatever the solution is, then you go through and with the value of C, be like, oh, is negative C what one of the outputs that it's giving here? If not, go on. Is this one of the outputs? If not, go on. So you could plug these into Desmos and just see which one numerically matches up. So hope that makes sense. We still have so many to get through, and I got a hard stop in 25 minutes, so I'm going to try and get through as much as I can. Wait, one of the factors are x plus 2b. I did not think about the exponents method. Yeah, again, that's something that came to me with a lot of practice and a lot of repetition, so it is what it is, but yeah. Okay, in the xy plane, we have a parabola with a vertex at 9, negative 14. Let's draw it out. 9, negative 14. It intersects the x-axis at 2 points, meaning it's going to go up. Again, just getting a rough drawing, nothing crazy. And hold on, 9, negative 14. And it's written in this, which of the following could be the value of a plus b plus c. So these ones are really cool because if you look, they gave you the vertex. So immediately you should be thinking of vertex form. And vertex form, all we got is a. We don't have b and c. But the reason why this is useful, or wait, let me show you. So we've got x minus 9 squared, minus 14, because that's negative 14. Right? It's always minus the x coordinate plus the y coordinate, but it's negative. So we have this in vertex form. Great. But how do I get a, b, and c? Well, watch this. What if I simplify this? X minus 9 squared is, if you FOIL it out, x squared minus 18x plus 81. You could write it out, multiply it by itself. You'll see that is correct. Minus 14. Oh, now I can simplify it. Distribute, distribute, distribute. Y equals ax squared minus 18ax plus 81a minus 14. Why is this useful? Because now I know a is a, fine. B is the value in front of the x, which is negative 18a, and c is this entire constant. Okay, because c represents that entire constant at the end. So a plus b plus c is a, plus negative 18a plus 81a minus 14. It's all of that added together. So that's negative 17a plus 81, 64a. So we have 64a minus 14. So this expression can be written like this. Okay. So it says, which of the following could be the value? Now the question is, what is a? I don't know, but I know one thing. Because remember in my drawing I said it opens up, right? We know when it opens up that a has to be positive. Okay? So a has to be positive. So can a be negative 3? No, it can't be. Can a be negative 1/2, negative 4? It can't be any of those. So in order to get something less than negative 14 for the value of this, we need this to evaluate to some negative number, right? Like to get negative 19, a times 64 has to be negative 5. That means a has to be negative, but a can't be negative. So we can't get negative 19. We can't get negative 23. So now we're down to these two values. What would a have to be in order to get 14? It has to be 0. I cannot have 0 as a because then it's no longer a parabola because we're zeroing out the x squared term. Goodbye. Whoops. I used my eraser. Goodbye. So the only possible answer is negative 12. And that would mean that a, whatever a is, a times 64 would be 2. So then it would be whatever, 1 over 32, right? So a, in this case, to get negative 12 would be 1 over 32, which is a possible answer. That's how you do it. Hope that made sense. Where can I find the question bank? Just Google College Board Digital SAT Question Bank, and it'll come up. All right, another one. X minus 29 equals this, blah, blah, blah. Which of the following are solutions of a given equation? So I know this one where a is greater than 30. And I think that the answers were... No, yeah, this is formatted weird. So it's a plus 1, and 29. Okay. So this is 1, this is 2, and this is 3. So I can see that 29 has to work right off the bat. Because when I plug in 29 here, I get 0. 0 times anything is 0. 29 minus 29 is 0. So we know 3 is legit. So anything without 3 is out. So now the question is it 1 and 2 or 1? You know, it's one of those two, right? One of those has to be legit. Again, you can do this in Desmos. You can plug this in. And you can choose an arbitrary value for, you know what? Let me show you how to do that. I'm going to actually do it this time instead of just describe it. So x minus 29 is equal to, what is it? X plus a times x minus 29. I think that was what it was, right? Yeah. Oh, x minus a, excuse me. Okay. And, oh, it's not letting me do a slider. Hold on. Let me get rid of this then. So if it doesn't let you do a slider, just put it in a separate thing. And then you can make a slider. Okay. So, and I'm going to set a to 3 arbitrarily. So we're going to look at the answer choices, right? We're AKA the intersection points of these two lines. One of them is going to happen when x equals 29. We already knew that that was a solution, right? Now the other point is here at 4. Okay. Well, what is 4 relative to a? A is 3. If my solution's at 4, that's at a plus 1. And those are the only two solutions. Remember, linear and quadratic, the max amount of solutions are going to be is 2. So this right here tells me a plus 1 is legit. And I don't see any other solutions. We're only going to have 2 solutions. So it's 2 and 3, which means C is the winner. Now I want to show you another way that you could have approached this algebraically without Desmos, which I think is actually pretty cool. You can also just plug in a plus 1 and for x. A plus 1 for x minus 29 is a minus 28, okay, is equal to, on this side, we're plugging in a plus 1 for x, so a plus 1 minus a times a plus 1 minus 29, right? I'm just replacing the x's. A and a cancel out. That's just a 1. That doesn't do anything. 1 times anything is just itself. 1 minus 29 is a minus 28. We get a minus 28 is a minus 28. That is a true answer. That means a plus 1 is indeed a solution. Boom, done. Okay, moving on. In triangle ABC, the measures of angle B is 90. Let's draw it out. 90. And we've got BD is an altitude. Oh, let's do a better drawing here because I already know what they're going to do. This looks like a mean proportional right triangle thingy. Okay. So I'll just make the drawing look a little bit nicer for you guys. So we have B is 90. We have AB is, hold on, what does it say? AB is 15. And the length of AC is 20. Okay. So AB is 15, and then AC is 23 greater than AB. So 23 plus 15 is 38. And then it says BD is an altitude. So we'll put that here. And I'm going to show you why this isn't good altitude. Because an altitude should come down from B, and it should form a right angle with that opposite side. Okay? And that's also going to be a right angle. Again, mean proportional right triangle, meaning we have 3 similar right triangles. They're all proportionate. Great. And 38 is this length. So it says, what is the value of BC over BD? Now, because these are similar triangles, what are they really asking? They're asking long leg BC. Long leg BC. Oh, no. BC over BD. I may have done that wrong. They're asking, in this little triangle, they're asking hypotenuse over little leg. You see? So if we just look at the big triangle, I know the hypotenuse. If I just know the little leg, which I do, I got my answer. Hypotenuse over little leg. And by the way, if you're not sure, if you're not convinced that this is the little leg, you can solve for BC with Pythagorean's theorem. 15 squared plus x squared is 38 squared. Here, let's do it. 38, basically it's 38 squared, therefore minus 15 squared, which is 1219, square root of 1219. That's a bad number. But let's just say 34.9. So you can see this is the longer side, right? So again, it's just 30, it's hypotenuse over little leg. 38 over 15, which means D is the winner. That's how you do it. It's going to be the exact same ratio. And you can also kind of tell, like, this is the hypotenuse. So you know the top part, the top part, BC is the hypotenuse of this little triangle. So we know we need a hypotenuse over little leg. So the value on top should be larger. So we could have also eliminated A and B that way. And then it's down to one of these two. Wonder where they got 23. Wait, did I do that math right? Oh, no, they just did 23 greater. So that's where they got it from. Okay, guys, I'm going to have to jump off pretty soon. Let me see this one. I think I might be able to do one more, and then we got to dip and call it a day. I know there's other problems that I haven't gotten to, but I've got to prepare for my next session today. I want to give some parting words before we end this amazing class. And all you people have been incredible. Thank you so much for joining and participating. It's been amazing. We got a lot of videos coming out this week, so make sure to subscribe to the channel if you haven't yet, because I want to make sure you're up to date on everything. All right. Type of sea turtle table shows original data set of numbers the turtle laid, 149, 144, blah, blah. A 6 nest with 121, let's call it F, 121, is added to create a new data set. Which of the following correctly compares the means of the two data set? Okay. So, by the way, we can just straight up do this in Desmos. So the original data set, so we have 149, 144, 148, 136, 139. We can calculate the mean. But the beautiful thing on Desmos, if you guys know, is obviously you add those up, divide by 5, or use the mean function. Watch this. Just put in the values. 149, 144, 144, 148, 136, 136, and 139. Okay. So we got a mean of 143.2. Now, they don't let you copy and paste in the Desmos on the real SAT. I'm just doing it just to show you this quickly. And now the new one, we have a new value of 132. Or sorry, what was it? Was it 132? No, 121, excuse me. Now, I already know the mean's going to be lower because if I'm adding a new value that's lower than the existing mean, it's going to lower the mean. But let's do it anyways. Let's pretend we didn't know that. All right, look at that. So the mean has dropped. So the new mean is going to be lower. Let's see. The mean of the original data set is, no, that's wrong. The mean of the original data set is greater than the mean of the new data set. That's it. So I hope that made sense, guys. Your most important piece of it, what's your biggest tips for the math portion of the data set? Oh, DSAT, great question. That's a big question, though. So, and I'm going to go back to the classroom, by the way, and I'm going to post it one more time. If there's any of you that are on the stream right now that have not yet signed up to our free JEDI class, make sure you join there. Everything is organized and laid out nicely. Again, this is the classroom tab, this is the community tab, but the classroom tab is where you can kind of get caught up if you're coming late to the party. But you got time. And remember, there's going to be lots of good videos. All right. So you want my biggest tip, man. In general, I would say my biggest tip is practice, practice, practice. Do as many practice tests as you can. That's going to get you set up most efficiently and effectively for success on the math portion of the SAT. If you're talking about advice now, Tuesday, 4 days before the SAT, I would say get familiar with Desmos. If you're just now starting to prep and cram, I would say get familiar with how to use Desmos and how to solve a lot of these problems with Desmos. I have a Desmos hacks video on my YouTube channel that you might want to check out. I'm going to do a huge one this week as well, but I would definitely recommend checking out Desmos hacks in general if you're kind of doing a triage at the end of the day. That's what I would say. Great question, MC. I lose time for the last two questions from Mod Math to Mod 2 Math. So should I start Module 2 from the... All right, so Cooking 800 is asking if they should start at the last question and work backwards. I don't think so. I don't like that method unless... I mean, look, everybody has a different approach and a different style, and if you've been practicing that and it's been working for you, okay, fine. But in general, I don't mind you getting to them at the end and getting them wrong. I'd rather you do more questions early on that are easier that you know you can get right, and then maybe getting burned on those ones. Now, I think there is something to be said, like some of the harder problems seem to be weighted more heavily. At least that's what the College Board is saying or alluding to, that some of these more difficult questions might have greater point values. But you're also going to have a lower probability of getting them right because they're very tricky. They're going to have even if you get like 80% there, you can still get it wrong if you miss like a little detail. Like remember that flux question? You know, so I would say I wouldn't change it up. I would start at the beginning, make your way through. I think that's your best strategy for success. So there you go. All right, guys. I guess this is it. I guess this is the end of our class for math. So thank you so much. Like I said, this is the first time we ever did this. Dan's going to be back on Thursday with this final verbal session. So make sure you guys join for that. But I hope you guys enjoyed this entire process. Like I said, make sure to sign up in the classroom in that link. If you haven't done so yet, make sure to leave a comment. If you have an additional question, if you're watching the replay. And last but not least, if you could click that like button if you haven't done so yet, it helps out the channel tremendously. So I really appreciate those signs of love and support. And heck yeah, let's do it. Everybody, thank you guys so much. Good luck to everybody. Remember, we're going to be back on Thursday, and I'm going to be making a ton of videos this week. So make sure to check in regularly so you can be up to date on all this amazing information that I'm going to provide you guys to get that 800 on the math portion of the SAT. You guys are all very welcome. Thank you guys so much for joining, and I will see you in the next video. Take it easy.